Yes. So today we are moving on to the next topic, which is solution of homogeneous partial differential equation of second and higher order with constant coefficients, right? So as I said earlier, if you have watched the ODE playlist that I have given in the Telegram channel yesterday, I think. So I think you can do this problem in your own, right? So only thing, if you have watched that video, the next 3 to 4 days will be very easy for you. You can do any problem in your own. So there we have solved ordinary differential equation of second and higher order with constant coefficients. Here we are going to solve partial differential equation of second and higher order with constant coefficients, right? So there we go. There we will have dy by dx plus d square y by dx square plus something etc. Here we are going to have dou square y by dou x square. That's it. The only difference is there we have solved ODE. Now we are going to solve PDE of second and higher order. I have written homogeneous here because a partial differential equation is said to be homogeneous if the equation, all the terms in the equation are of same order, right? Order. For example, consider this equation: dou square z by dou x square plus dou square z by dou y square. Now you can see the order of the first term is 2 because it is second derivative, and again here also the order is 2. So every equation, if you have same order, that is called homogeneous. Suppose if I have dou cube z by dou x square plus dou square z by dou y square, we can see this equation is ordered, this term is ordered 3, this term is ordered 2. So this is not homogeneous. So a partial differential equation is said to be homogeneous if every term is of same order. Order means the number of times you are differentiating. So here 3, here 2. So therefore this equation is not homogeneous, but this equation is homogeneous. So now we are going to solve homogeneous partial differential equation of second order, third order, fourth order, any order it can be, right? Yes. The same way as we did in the ODE, we are going to divide this into 5 cases: case 1, case 2, case 3, case 4, case 5, depending upon the RHS, right? I am assuming that you have watched ODE playlist that I have said earlier, right? I am assuming that. So there we have we have categorized that in RHS into 5 types, I think. RHS is of the form 0, RHS is of the form e power ax, type 3 is RHS is of the form sin ax or cos ax, type 4 is RHS is of the form x power n, type 5 will be RHS is of the form e power ax into cos ax or sin ax. So we are categorized into 5 parts. So here also we are going to categorize like this. So first, you know what's meant by homogeneous, right? So every term is of equal order, then we say that equation is a homogeneous equation, homogeneous partial differential equation. So we need to find the solution for that, right? We need to find the solution for that. So for example, so we will have some partial differential equation. So this is a partial differential equation. For example, d square. Okay, let me write. Now we are going to introduce some terms. Yes. So whenever we have dou square z, so whenever we have dou square z by dou x square, we are going to write this term as d square. So whenever you are going to have dou square z by dou y square, we are going to write this term as d dash square. So whenever we are going to have dou square z by dou x dou y, we are going to write this term as d into d dash, right? So if I have a dou cube z by dou x square, we will write d cube. So if we have dou square z, dou cube z by dou y cube, we will write that as d dash cube. So in general, dou power n by dou x power n, we will write this as d power n, right? So this for in general, we are going to write this dou power n z by dou y power, this just a notation, right? So we are going to write this as d dash whole power n. So these are the three notations that we are going to use, right? So our equation will be of the form. So for example, if I have a partial differential equation, dou square z by dou x square plus 2 into dou square z by dou x dou y plus 3 into dou square z by dou y square. So we will have some equation like this. So RHS, we are going to split this into 5 types, right? So this is a partial differential equation of order 2. You can see every term is of order 2, right? This is order 2, this is order 2, this is order 2. So therefore it is a homogeneous also, and it is second order homogeneous partial differential equation, right? Similarly, we can also have third order also. So if we will have some equation like this, is equal to, we are going to divide this into 5 cases. The first case is RHS is 0. RHS is 0. So this is some equation. This will be, I have written this for example, right? So we will have some equation like this is equal to, first case is RHS is 0. So second case is, in ODE we will have e power ax. Here we are going to have e power ax plus by, because it is a function of 2 variable. ODE only 1 variable. So RHS will be e power ax. So here we are going to have type 2 as e power ax plus by. Type 3, there we will have sin ax or cos ax. Here we are going to have sin ax plus by or cos ax plus by, right? Yes. So in type 4, in ODE we will have x power n. So here we are going to have x power r, y power s, some degree, right? R and s may be some integers, x square, y square. There you will have only x power n, you will have only x. Here you are going to have 2. The only thing is I am extending the variable, that's it. In ODE we have only one variable here, e power ax, sin ax, x power n. Here we have only 2 variables. So the last case is e power ax plus by into sin ax. Okay, let me write. So we will write this as T1. We will do this as T2, and this is T3, and this is T4. So type 5 will be T2 into T3. So in question we will have e power ax plus by into sin ax plus by, or e power ax plus by into cos ax plus by. This is type 5. So in type 6 we will have type 2 into type 4. So question will be of the form e power ax plus by into x power r, y power x. The question will be of that form. So we have 6 types, right? So we will have some second order or third order. Order can be anything here. Is equal to something. So we are splitting this into 6 cases. The first case is RHS is 0. Second case is e power ax plus by, sin ax plus by, cos ax plus by, x power r, y power s, and T2 into T3 is the 5th case. T2 into T4 is the last case, that is sixth case. Now we need to find the solution for this 6 cases now, right? So again, as we did in the ODE, the general solution is characteristic function plus particular integral, right? So general solution is y is equal to CF plus PI. So same as there, for if the RHS is 0, there is no particular integral. There is no particular integral. For here we will have particular integral. So here the general solution is, I am speaking everything, I am assuming that you have watched the ODE playlist, right? I have given 2 days time for you, right? So the general solution is y is equal to complementary function plus particular integral. So we need to find complementary function, and then we need to find particular integral, and then we need to add to get the solution, right? So CF is same for all 6 types, right? So no matter about RHS, CF is same for, the method for finding CF is same for all 6 types, because when we are going to solve this equation to find CF, and particular integral will be varied depending upon the RHS, right? So first we will see how to find characteristic function. So if you have watched that ODE playlist, you will be have found characteristic function by just putting D is equal to M, right? If you put D is equal to M, you will have some quadratic equation here. If I solve the quadratic equation, we will have 2 roots. So depending upon the 2 roots, we will classify them as roots are real and equal, roots are real and distinct, roots are imaginary. So we will have characteristic function for every type. So for so that same way we are going to do this also, right? So first we will move on to type 1. Type 1 is RHS is 0. So before moving there, first I'll give the formula to find the characteristic function, right? To find the characteristic function. So for type 1, it is enough for only to find the characteristic function. There is no particular integral because RHS is 0. So first I'll give the notes for finding the characteristic function. So in ODE we have 3 characteristic functions, right? Depending upon the roots. Here we are going to have only 2 characteristic functions. So first I will write the formula for characteristic function. So everything you will be understand if you have watched the ODE playlist. So characteristic function, procedure to find CF, characteristic function. Right. So here we are going to have only 2 cases for characteristic function. If the roots are different, roots are distinct, we are going to only have 2 cases here, right? It is not that real and distinct, real and equal, imaginary. So we have 3, but here we are going to have only 2. The first is roots are different. Roots are different. So we need to solve this equation. So let me first write the formula. If you do the formula, it will be very easy for you. Roots are different. For example, if I have 2 roots m1, we can have n roots also. If I have an equation of order 2, we will have 2 roots. If I have an equation of order 3, we will have 3 roots. If I have an equation of order 4, we will have 4 roots. For example, if I have 4 roots, m1, m2, m3, m4. Okay, let me now limit only to 2 roots. For if I solve this equation, we will get 2 roots. So if I let m1, m2 be the 2 roots, then the characteristic function is phi1 of y plus m1x plus phi2 of y plus m2x. That's it. Suppose if I have 3 roots, you just extend to phi3 of y plus m3x. If I have 4 roots, 4 distinct roots, then extend to phi3 plus phi4. So in general, you can write this for n roots. So if I have 2 roots, phi1 of y plus m1x, phi2 of y plus m2x. If I have 3 roots, phi3 of y plus m3x, you can just extend so on. Second is roots are equal. Suppose the roots are equal. Suppose if I have 2 roots, let us say m1, m2, and if m1, m2 are equal, then the characteristic function is phi1 of y plus mx plus x into phi2 of y plus mx. Suppose if I have 3 roots, you just add the term x square phi 3 of y plus mx. If I have 4 equal roots, add x cube plus phi 4 of y plus mx. If I have 5, just add x power 4 phi 5 of y plus mx. So first you will write only for 2 and then you will extend for n. So here you just add phi 3 of y plus m3x, phi 3 of y plus m4x. If I have 4 roots, here you have to add with x square, x cube and so on. So there are only 2 possible here. Remember, here I have not mentioned real. Even if we have complex roots, that comes under different roots. For example, if I have when solving the quadratic equation, suppose if I get 2 plus or minus I. So in ODE, we will write a separate characteristic function for this, e power alpha x a cos beta x plus b sin beta x. But here it is not separate for this. We have to treat this as distinct roots. You have to treat this as distinct roots and then you have to substitute here. M1 2 plus I, M2 is 2 minus I, right? So here there are only 2 possible. I don't care about whether it is real or imaginary, only 2. Roots are different, roots are equal, right? Yes. Now we need to solve this equation and we need to solve this equation to find the characteristic function. Now we will write the procedure for solving this equation, right? Yes. So written formula for a characteristic function. So procedure, right? So we will have some second order or third order or any order is equal to some RHS that is I mentioned here. It can be of type 1, type 2 or type 3. It can be of type 1 to type 6. The RHS can be anything. So here we are going to have a partial differential equation. So first here we need to we know that the general solution is y is equal to complementary function plus particular integral, right? So first we will learn how to find characteristic function. So you take this equation alone. You take this equation, you replace in this equation, you replace d is equal to m. You replace d is equal to m and d dash is equal to 1. That's it. If you do this, you will have a quadratic equation or a cubic equation depending upon the order. If you do this, this equation will be a quadratic equation. If I substitute d is equal to m, remember d is dz by dx, and if replace d dash to be equal to 1 and then you solve for d or you solve for anything, right? Suppose you solve for d, so you will get the roots. So depending upon the roots, you use either this formula or this formula. So first let me do the problem and then it will be very easy for you. So now we are moving on to type 1. RHS is 0. Again I am repeating, if you have watched the ODE playlist, this will be very easy for you, right? Yes. So first we will move on to type 1. So type 1 is RHS is 0. So if you haven't understand up to this, not at all a problem. If I do the work out the problem, it will be very easy for you. So type 1. Type 1, RHS is 0. RHS is 0. So we will move on to the first problem. The first problem is solve d dou square z by dou x square minus 4 into dou square z by dou x dou y plus 3 into dou square z by dou y square equal to 0. Now we can see this is a second order homogeneous equation. Why it is homogeneous? Order 2, order 2, order 2. So homogeneous, it is second order. So we need to solve using characteristic function and particular integral, and this comes under case type 1. Why? Because our RHS is 0. So the general solution is y is equal to CF alone. We don't have plus PI. So for finding the CF, what I said earlier, so I can rewrite this equation to be d square minus 4d d dash plus 3d dash square of y equal to 0, right? Because as I said earlier, d square is dou square z by dou x square, dou square z by dou x square is d dash square. So here we have 3 and d dash is dou square z by dou x dy. Now we need to find the roots. To find the roots, what we need to do? So first we need to find characteristic function. So for characteristic function we need to replace d is equal to m, d dash is equal to 1, right? D is equal to m, d dash is equal to 1. So this equation turns out to be m square minus 4 m into 1 plus 3 into 1 square equal to 0, right? So in here you replace d is equal to m, d dash is equal to 1. So here this equation turns out to be m square minus 4m plus 3 equal to 0. This is nothing a quadratic equation. Now you solve this equation, you will get two roots. So depending upon the roots, you choose either this formula or this formula, right? So we will solve this equation, m square minus 4m plus 3. So we have m square minus 4m plus 3 equal to 0. So when you solve this, you will have m is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this turns out to be 4 plus or minus 16 minus 4 1 into 3 divided by 2 into 1. So this turns out to be 4 plus or minus square root of 4 divided by 2, right? 16 minus 12 is 4. So this turns out to be 4 plus or minus 2 by 2. So 4 plus 2 by 2, so 6 by 2. 6 by 2 is 3 and 4 minus 2 by 2 is 1. So therefore roots are real and we don't need to write real, roots are different. So what is our m1? You can choose any one. m1 is 1, m1 is 3, m2 to be equal to 1. Now what will be the characteristic functions? The characteristic function is phi1 of y plus m1x, so m1x is 3x plus phi2 of y plus x, 1 into x, that's it. This is the characteristic function, and also this is the solution, because if RHS is 0, the general solution is y is equal to CF alone. So for finding CF, you need to replace d is equal to m, d dash is equal to 1. You will have a quadratic equation, solve the quadratic equation, and depending upon the nature of roots, you choose either this formula or this formula, so you will get the characteristic function. If you have any doubt in this, you can ask. If you understand this, you can do any problem in your own. The only thing is, if you have RHS is equal to 0, you put d is equal to m, d dash is equal to 1, right? So this equation turns out to be a quadratic equation. Solve the quadratic equation. You have two roots. So in ODE, what you will do is, you have only d square something etc. You replace d is equal to a there. In ODE playlist, we will replace d is equal to m. We will replace d is equal to m. Here we are having two substitution. D is equal to m, d dash is equal to 1, right? Can you move on to second problem? So suppose if I have some RHS like e power ax plus by, we have to find CF and then we have to continue finding particular integral, right? So for finding characteristic function, this is the same method for all types, right? So RHS can be anything. The characteristic function, there is only one method to find characteristic function, and the characteristic function either it is this or this. For any question, the answer will be either this or this. Our m1, m2 will change. So depending upon the answer, our m1, m2 will change. And for if you have some if you have some other like, you have to find particular integral also, right? Yes. Clear? Can you move on? So we need to solve this equation, that's it, right? Second order equation. So what this says is, any function of the form y plus m1x and y plus m2x, this will be a solution for that. Okay, now we'll move on to second problem. So you just note these two, now mug up now itself, y plus m1x, y plus m2x. If you have equal roots, if you have two equal roots, stop up to x. If you have three equal roots, add x square plus v2 of y plus mx. So I'll move on to second problem. Solve d square minus 2dd dash plus d square of z equal to 0. So in the last problem I have written y, so just change this to z because all are function of z, because z is independent variable. Okay, so the d square is same as, so in the exam point of view they can either give this equation or dou square z by dou x square minus 2 dou square z by dou x dou y plus dou square z by dou x square is equal to 0. Both are same. So we need to find the general solution. Again you can see this is a order 2 equation because order 2 homogeneous equation, and it's second order equation. So we need to solve this using characteristic function particular integral, and since answer is 0 there is no particular integral. So the general solution is y is equal to CF alone because we don't have RHS here. So for finding the, first we will find CF. So for finding CF you have to replace d is equal to m, d dash is equal to 1. So this equation becomes m square minus 2m into 1 plus 1 square is equal to 0, right? So you need to equate this term to 0 after replacing this. So we have m square minus 2m plus 1 whole is equal to 0. So I can write this as m minus 1 whole square is equal to 0. So the roots are 1 and 1. So we have equal roots, and there are two roots. So what will be the characteristic function? Phi1 of y plus m1x. So our m1 is 1 plus x into phi2 of y plus mx. So we have only one m here because of equal roots. So x into phi2 of y plus x. That's it. This is the general solution. Our y is same as CF. So y is also phi1 of y plus x plus x into phi2 of y plus x. That's it. So we'll move on to third problem. We are in type 1, RHS is 0. The third problem is 2 into dou square z by dou x square plus 5 into dou square z by dou x dou y minus 3 into dou square z by dou y square equal to 0. So the general solution is y is equal to complementary function. That's it. You don't have particular integral. So for finding the complementary function you need to replace d is equal to m, d dash is equal to 1. So if we do that, this will be 2m square plus 5m. This equation is same as d square plus 5dd dash minus 3d dash square equal to 0. Both are equivalent. So if we replace d is equal to m, d dash is equal to 1, so there will be 5m minus 3 is equal to 0. Now to solve this equation. So our m will be minus b plus or minus square root of b square minus 4ac divided by 2a. So it will be minus 2 plus or minus 5 plus or minus square root of, so 25 minus 4 into 2 into minus 3 divided by 2 into 2. So this will be minus 5 plus or minus, so here we are going to have 4 2s are 8, 24, so we will have 49 by 4. This will be minus 5 plus or minus 7 by 4. So the first root is minus 5 plus 7 by 4, second root is minus 5 minus 7 by 4. So this means 7 minus 5 is 2, 2 by 4, 2 by 4 is 1 by 2, and this is minus 12 by 4. So minus 12 by 4 is minus 3. So therefore roots are distinct, roots are different or distinct, roots are different. So what will be my characteristic function? Characteristic function is P1 of y plus m1x plus P2 of y plus m2x. We can stop up to this because we have only 2. Suppose if I have 3, we should add phi 3 of y plus m3x. So this is phi 1 of y plus our m1x is 1, m1 is 1 by 2 and our m2 is minus 3. So we have the solution is, and also y is same as CF, and solution is y is equal to phi 1 of y plus x by 2 plus phi 2 of y minus 3x. Now we can do this problem. It can just take 2 minutes. The fourth problem is d square minus d dash minus 6d dash square of z equal to 0. Just tell only the roots, right? If you know the roots, you can just plug in this formula, just only the roots. Just take 2 minutes. Yes, so the answer is z equal to, sorry, I have written a general solution y is equal to CF, right? Change that to z is equal to CF. Sorry, one mistake. Right, please change to z is equal to CF, right? So OD only you will type y because here the independent variable is z. So just change to z is equal to CF, right? So the solution is z is equal to CF, it is not y is equal to CF. So you please change, yes, you please change to z is equal to CF, not y is equal to CF. The general solution is z is equal to CF plus Pi, right? Z is equal to CF plus Pi. It is not y is equal to CF plus Pi, it is z is equal to CF plus Pi because our independent variable is z here, right? So please change to z is equal to CF plus Pi. Here we are going to have only z is equal to CF for this problem. And the solution is phi 1 of y minus 2x plus phi 2 of y plus 3x. This is the solution. So I will move on to the fifth problem. The fifth problem is solve d cube plus d dash square minus d square d dash minus d dash cube of z equal to 0. This is the equation of order 3. You can see every term is of order 3, order 3, order 3, order 3, order 3. So we will have 3 roots. So first the general solution is general solution is z is equal to cf, right? You please change z is equal to cf. So first we will find cf. So for finding cf, we need to replace d is equal to m, d dash is equal to 1. So if we do this, this equation will be m cube plus d m into 1 square d square m square into 1 minus 1 cube is equal to 0. So we have m square plus m minus m square minus 1 equal to 0. So this equation is m cube minus m square plus m minus 1 equal to 0. The cubic equation. So cubic equation, yes, I changed. So m cube minus m square plus m minus 1 equal to 0. So this is a cubic equation, right? It's a cubic equation. The lighting is very poor in this room. There is only one light. So this is a cubic equation, right? M cube minus m square plus m minus 1 equal to 0. Now you can solve this equation to get 3 roots. So depending upon the 3 roots, you write characteristic function. So first you will find 1 roots, right? Clearly, if m is equal to 1 is clearly a root. You can see if m is equal to 1, this will become 1 minus 1 plus 1 minus 1. So this all will get cancelled. So therefore 1 is one of the root. We can find another 2 roots by L method, right? L method. So we will write 1 here. What are the coefficients? 1 minus 1, here 1 minus 1. So first you have to write 0. 1 plus 0 is 1. 1 into 1 is 1. Minus 1 plus 1 is 0. 1 into 0 is 0. 1 plus 0 is 1. 1 into 1 is 1. This will be 0. This is the coefficient of m square. This is coefficient of m. This is constant term. So if you form this equation, if you form a quadratic equation from here, we will have m square plus 0m plus 1. So m square plus 1 is equal to 0. If we solve this equation, that m square is equal to minus 1. That means m is equal to plus or minus I. Right? So what are the roots? The roots are, so roots are 1 I minus I. So you don't about complex, right? So in ODE only, if you have complex roots, we will write e for alpha x a cos beta x plus b sin beta x. Don't worry about this. So roots are 1 I minus I, which are distinct. All are different roots. So what will be characteristic function? I'll let here phi1 of y plus m1x. So m1 is 1. So 1x plus phi2 of y plus our m2 is ix plus phi3 of y plus y minus ix, because m3 is minus I. So therefore our z is same as cf phi1 of y plus x, y plus ix, y minus ix. So we will move on to the 6th problem. So it's very easy. The only thing is you have to replace d is equal to m, d dash is equal to 1. You have to solve the equation whether it is quadratic or cubic or it is biquadratic. Depending upon the roots, you need to write the characteristic function. That's it. Very simple. So 6th problem. Sixth problem is solve d power 4 minus d dash power 4 of z equal to 0. It is a homogeneous, right? So everything I am saying I written CF, right? That is formula for homogeneous only. It is not for non-homogeneous. Suppose if I have d cube here, that CF will not work out, right? So we have only homogeneous. So d power 4 minus d dash whole power 4 z is equal to 0. So first we will have to find the general solution. So general solution is z is equal to CF. We will not have PI. So for finding CF, what we need to do? We need to replace d is equal to m. Suppose in the exam, if they give equation like dou power 4z by dou x power 4 minus dou power 4z by dou y power 4 equal to 0, don't get confused. This equation is same as this, right? So if you straight away give like this, it will be easy for you to see. But if you give this equation, don't think we have studied this type of equation. This is same as d power 4 minus d dash power 4 is equal to 0. That's it, right? Yes. So d is equal to m, d dash is equal to 1. So this equation turns out to be m power 4 minus 1 is equal to 0. Now we need to solve for 4 roots. So how can I do this? I can write m square whole square minus 1 square equal to 0. So therefore I can do a square minus b square formula, m square plus 1, m square minus 1 is equal to 0. If I solve this, I will get m is equal to I, m is equal to minus I. So here we have two roots, right? I minus I. Here we have I minus I. If I solve this equation, I have minus 1 plus 1. So we have 4 roots. All 4 are distinct. So what will be my CF? You can write this straight away, right? I think you can do this, right? So what will be my CF? Z is same as CF, and that is same as P1 of y plus Ix plus P2 of y minus Ix plus P3 of y minus x plus P4 of y plus x. So instead of m1, m2, m3, m4, I have written I minus 1, 1. So I will give you some problem for you to work out now. That's it. For type 1, we have finished type 1. So we have solved 6 problems. Now I will give you some more problems, right? It is not, you can also solve any, if I give any problem, you can solve in your own. Because you have only what you are doing here is you are only solving an equation. That's it. If you know how to solve an equation, then any problem you can do for finding the characteristic function. If it is of order 2, we are going to get a quadratic equation. We are going to use the formula minus 2 plus or minus square root of b square minus 4ac by 2a. And if it is a cubic equation, you have to find one roots by trial and error method, and then you can find another 2 roots by quadratic method again. And if you have some 4, you will not get an equation of 4th order because it is not easy to solve 4th order equation. If you have get the 4th order equation, it will be some easy equations like you can get the 2 roots easily, right? That's it. So now I will give you some problems for you to work out. Yes, we are moving on to type 2. Before that, I will give you some problems for you to work out. So from now on, you can find characteristic function for any problem, and we will find, yes, we will move on. So I will give you some 4 problems for you to work out, so that you will have 10 problems overall. D square minus d dash, you take this as exercise 30 d dash square of z equal to 0, and 5d square minus 12d dash minus 9d dash square z equal to 0. D cube minus 4d square d dash plus 4d d dash square of z equal to 0. The last problem is dou cube z by dou x cube minus 2 into dou cube z by dou x square dou y minus 4 into dou cube z by dou x dou y square plus 8 into dou cube z by dou y cube is equal to 0. So this is nothing but d dash square, right? D dash square. This is nothing but d dash d square. So you can also note like dou n z by dou x n minus 1 dou y is equal to d power n minus 1 d dash. And dou n z by dou x dou y n minus 1 is equal to d dash whole power n minus 1 into d. Right. So now we'll move on to, we have already solved this type of problem, right? This is nothing but d dash square. Sorry, d dash d square, right? This is nothing but d dash d square. You can see our n is 3 n minus 1. So this is nothing but d square d dash, d square d dash, here d dash square d. And this already written, right? Dou n dou z by dou x power n is d power n, and dou n z by dou y power n is equal to d dash power n. So these, with these three you can do this anyway, right? So now I move on to type 1. So type 1 will be RHS will of the form e power ax plus by. So for that what you have to do is, the general solution is CF plus particular integral. So we'll move on to the first problem in type 1. Okay, I'll tell you the procedure and then we'll move on to first. So type 2, type 1 is RHS is 0. So RHS is of the form e power ax plus by. So here the general solution, z is complementary function plus particular integral, right? So same way we will have some equation like this. Instead of 0 we are going to have e power ax plus by, and by can vary. A and b are some numbers, e power 2x plus 3y, e power 5x minus 4y, you can have anything. So CF is same. For finding the CF, you need to equate this term to be equal to 0 by putting d is equal to m, d dash is equal to 1, so that you will get characteristic function. Now here we need to find particular integral. So for finding particular integral, what you need to do is 1 by the question which is given. For example, if we take, suppose if I have a question like this, here we are going to have, this is a function of d and d dash, right? I can simply write any equation can be. This equation will be a function of d and d dash, and here we are going to have e power ax plus by. So for finding particular integral, 1 by given this question into RHS. Our RHS is the given question e power ax plus by. Here what you need to do is only one substitution. The one substitution is replace in an ODE. What you will do is you replace d by a, right? D by a. If you get denominator as 0, you will multiply x and then you differentiate the denominator. Same way I am going to do here. Here what you need to do is replace d is equal to a, d dash to be equal to b, right? So compare and study. In ODE you will replace d to be equal to a. If the denominator is non-zero, that is the particular integral. If the denominator becomes 0, you need to multiply x and then you need to differentiate the denominator and then you will plug again. If the denominator is non-zero, that is a particular integral. If not, we will multiply another x and then we will differentiate the denominator again. The same way we are going to do. Before that, we will replace d is equal to a, d dash is equal to b. If this denominator is non-zero, after substituting d is equal to a, d dash is equal to b here, you will get some number. If the number is non-zero into e power ax plus by, then this is the particular integral. Suppose if after plugging d is equal to a, d dash is equal to b, if you get 0, what you have to do is you have to multiply x and then you will differentiate the denominator, that is f dash of d comma d dash into e power ax plus by. Now you need to substitute again d is equal to a, d is equal to a, d is equal to b. If this denominator is non-zero, this is the solution. If this becomes again 0, what do you need to do? You need to multiply another x, so this becomes x square. You will differentiate this term again, and then you have to substitute again d is equal to a, d is equal to b. You have to proceed as long as you should not get a non-zero. You have to proceed until you get a non-zero denominator. Suppose if here itself it is non-zero, this is particular integral. If this is 0, multiply x, differentiate the denominator, again you substitute d is equal to d is equal to b. If this is non-zero, this is the particular integral. Suppose if again this is equal to 0, you multiply x again, so this becomes x square, differentiate the denominator again you substitute d is equal to d is equal to b. If that becomes non-zero, that is the particular integral. If that also becomes 0, you proceed as long as you didn't get the non-zero denominator. This is the procedure. So we will do problem, then it will be very easy for you. So first problem we will do now. So just recall the procedure, right? Yes. CF is same for all problems. So we'll move on to the first problem. The first problem is dou square z by dou x square minus 5 into dou square z by dou x dou y plus 6 into dou square z by dou y square is equal to e power x plus y. Now you can see this is a homogeneous partial differential equation, and you can see every term is of order 2, so therefore it will be homogeneous. And you can see RHS is either of the form e power ax plus by. So this comes under type 2. So in the previous problem type we have RHS to be equal to 0. Here we are going to have RHS to be equal to e power x plus y. So what will be my general solution? So general solution is z is equal to complementary function plus particular integral. I think you can find complementary function in your own from any problem, right? So first, since the first problem, I will do complementary function also. So complementary function, so I can rewrite this equation to be d square minus 5 d dash plus and this is d dash square of z equal to e power x plus y. So for finding characteristic function, we need to you have to consider only this equation. I don't care about RHS. So replace d is equal to m, d dash to be equal to 1. Same method for characteristic function. So this becomes m square minus 5m plus 1 equal to 0. So we can find the two roots, right? So after you find two roots, so our m will be 5 plus or minus square root of 25 minus 4 into 1 into 1 divided by 6. So 6 divided by 2 into 1. So this will be 5 plus or minus square root of 1 by 2. So 5 plus 1 by 2 is 1 root, 5 minus 1 by 2 is another root. So we have 6 by 2. So 6 by 2 will be 3. Here we are going to have 4 by 2 is 2. So therefore our characteristic function is phi1 of phi1 of y plus 3x plus phi2 of y plus 2x. If the RHS is 0, this is the solution also. But here we need to find the particular integral. So 1 by, what is the given question here? D square minus 5d dash plus 6d dash square into RHS, or RHS is e power x plus y. So here when you compare this with e power ax plus by, our a is 1, b is also 1. Compare with e power ax plus by, a is 1, b is also 1. So the procedure is you have to replace d by a, d dash by b. That is our procedure, right? So here we need to replace d by 1, d dash by 1, because both are, a is also 1, b is also 1. So if we replace this, the denominator becomes f of a comma b. So this becomes 1 square minus 5 into 1 into 1 plus 6 into 1 e power x plus y. So you can see this will be 1 divided by 1 minus 5 plus 6 e power x plus y. So 1 minus 5 is minus 4, which is 1 by 2 e power x plus y. You can see we get a non-zero denominator first itself. Therefore, this is the particular integral. Suppose if this becomes 0, you need to multiply x, you need to differentiate the denominator, right? And then you need to substitute again. But since denominator is non-zero, this is the particular integral. So therefore, what is the general solution? Cf plus pi. So add up this term and this term. So move on to next problem. Clear, right? So when you are differentiating with respect to d, suppose if this becomes 0, you need to differentiate this with respect to d. So you can consider d dash to be constant, right? So we will do problem. So when you are differentiating this with respect to d, you can consider d dash to be constant, because we are differentiating partially, right? So we'll move on to the next problem. So I think you can do any problem from now on. So let me give you one more problem for you to practice. So the second problem is dou square z by dou x square, minus 4 into dou square z by dou x dou y plus 4 into dou square z by dou y square equal to e power 2x minus y. Right? You can just take 2 or 3 minutes to quickly do this problem. Here our a is 2, b is minus 1. So same way, the characteristic function you can do this very easily, right? So if you replace this is d square minus 4d d dash plus 4d square, replace d is equal to m, d dash is equal to 1, you will get a quadratic equation. Solve that, you will get 2 roots. And so you just find particular integral for this, right? Because it's time based for finding characteristic function, you quickly find particular integral only. So if you do particular integral, here we are going to have d square minus 4d d dash plus 4d dash square e power 2x minus y. Now you replace d is equal to a is 2. So that means d is equal to 2, b dash is equal to minus 1. So if we get a non-zero denominator, then this is a particular integral. Suppose we get 0, we have to follow some other method. But this problem you will not get a non-zero denominator. If you are down, you can just take yes or no, so I will move on to next problems. So after finishing this, we have only 4 topics left: heat equation, Laplace equation, and then a canonical form. That's it. If you finish these 3 topics, the syllabus will be over for you. I think we can finish the syllabus as early as I said 20 days, but I think I finish this in 15 to 16 days itself. So I'll just write down the answer for this. So the answer for this is z is equal to phi1 of y plus 2x plus x into phi2 of y plus 2x plus 1 by 16 e power 2x minus y. This is the answer for this, right? That means here you will get equal roots to be plus or minus 2. You can straight away write this to be m minus 2 whole square. You can straight away write this equation to be m minus 2 whole square. So that is 2 and 2 are equal roots, and you can just split d is equal to 2, d is equal to minus 1, you will get 16 as a denominator, that is not 0, therefore this is a solution. So move on to the third problem. The third problem is solve d plus d dash whole square of z equal to e power x minus y. So you can also take this as a plus b whole square formula, so you will get a normal standard form, d square plus 2d d dash plus d dash square. So anyway, so first we will find the general solution. So what is general solution? It is CF plus particular integral. So first we will find CF. So for finding CF, we need to replace d is equal to m, d dash is equal to 1. So therefore this equation turns out to be m plus 1 whole square equal to 0. That means minus 1 comma minus 1 are 2 equal roots. So what will be my CF? It is phi1 of y minus x plus x into phi2 of y minus x. Now we need to find the particular integral. So we will write the particular integral. So 1 by, so it is d plus d dash whole square into e power x minus y. So our a is 1, b is minus 1. So we need to replace d by 1 and d dash by minus 1, right? So d, you have to replace d by a, d dash by b, a is 1, b is minus 1. So if we do that, here we will get 1 minus 1 whole square e power x minus y. So here we have 0. So therefore this cannot be a particular integral. So for that, what do we need to do? We need to differentiate this denominator. We will mark that as equation number 1. So 1 becomes multiply x, differentiate the denominator with respect to d. So for differentiate this denominator with respect to d, we will have 2 into d plus d dash, and if you differentiate inside, you will have 1 plus 0. So 2 into d plus d dash, yes, 2 into d dash e power x minus y, right? So multiplied x, differentiate the denominator. Now you again replace d is equal to 1, d dash is equal to minus 1, because our a is 1, b to be minus 1. Now you can see again this denominator is equal to 0. So 2, 1 minus 1 e power x minus y. So again denominator is equal to 0. That means this is also not a particular integral. So we have to differentiate 2 again. So we differentiate 2 again. I'll erase off a particular erase of complementary function. This is a complementary function. So you need to differentiate, multiply x and differentiate denominator as long as you did not get the 0 denominator. So if 2 becomes, so this is also to be x cube, sorry, x square, because we already have x here. And if I differentiate this denominator, I will have 2 into derivative of d is 1, d dash is 0, e power x minus y. So this means x square into 1 by 2 e power x minus y. We don't even have d and d dash to replace here. So already you have a non-zero denominator. This is the particular integral. Suppose if I have some equations like d plus d dash, you replace d is equal to 1, d dash is equal to minus 1. But here we will get a constant term itself while differentiating. So we can stop at this stage. So our particular integral is x square by 2 e power x minus y. X square by 2 e power x minus y. So our general solution is z is equal to complementary function plus particular integral. You need to add both the terms to get the general integral, general solution. Move on to third problem now. Again, from now on you can do any problem in type 1 and type 2 as easy. If you have ODEs, if you have studied ODE, then this will be very easy for you. So the third problem is solve d cube minus 3 into d dash square plus 2d dash cube of z equal to e power 2x minus y plus e power x plus y. Right? Here we have two terms in the RHS. So what will be my general solution? The general solution is z is equal to complementary function plus pi1 plus pi2. Right? For pi1 we have to take this as RHS, and for pi2 you have to take e power x plus y as RHS. Right? So first we need to find characteristic function, and then we find particular integral pi1, and then we find pi2 also. So first we will find the characteristic function. So our characteristic function, you need to replace d by m, d dash to be equal to 1. So if we do that, this will become m cube minus 3m plus 2 equal to 0. Right? M cube minus 3m plus 2 is equal to 0. So clearly you can see 1 is one of the root, because if m is equal to 1, then this equation will be 1 minus 3 plus 2, this is equal to 0. Therefore 1 is one of the root. So the coefficients are m cube is 1, there is no m square term, so 0, and this is minus 3 and 2. I think you can do this very easily. Now this is the coefficient of m square, this is coefficient of m, this is constant term. So we have m square plus m minus 2 is equal to 0. Now you solve this quadratic equation, you will get the answer to be, the two roots are 1 minus 2. So what will be my characteristic function? So what are the roots overall? 1, 1, minus 2 are the roots, right? The roots are 1, 1, minus 2. Remember, for these two we have to write equal roots formula, and for minus 2 you have to write distinct formula. So minus 2 is distinct, so I can write CF, I don't know whether it is visible, I can write CF to be phi1 of y minus 2x, this is because this is distinct. For these two I am going to write phi2 of y plus x into phi2 of x into phi3 of y plus x, that's it. So for this I am writing equal to distinct roots formula, and for these two I am combining equal roots formula with m to be equal to 1. So phi2 of y plus x into phi3 of y plus x. So now we will find pi1. So what is our pi1? 1 by d cube minus 3d dash square plus 2d dash cube into e power 2x minus y. Now you have to replace d by 2 because our a is 2 and d dash by minus 1. So if I do this, you will have 1 by, so d cube is 2 cube, 3 into 2 into minus 1 plus 2 into d dash whole cube into e power 2x minus y. So this is equal to 2 cube is 8 and this is plus 6 and this is minus 2 into e power 2x minus y, and 8 plus 6 is 14 minus 2 is 1 by 12 e power 2x minus 2. This is the pi1 because we got the non-zero d dash minus 1 okay minus 1 square, sorry, minus 1 square. So this will be this will be 8 minus 1 square is plus 1, so 8 minus 6 minus 2. So again this is equal to 0 because 8 minus 6 is 2, 2 minus 2 is 0. That means you need to multiply x, so this is 0 form, or you can also call absurd. So x into 1 by, you differentiate the denominator, so this will be 3d square, this d will be 1 minus 3d dash square, this will be 0. Differentiate with respect to d, you can treat d dash to be constant, and here e power 2x minus y. Now you replace d to be equal to 2, d dash to be equal to minus 1. So if I do that, you will have 3 into 2 is 6 and here minus 1 square. So minus 3 d dash square. So d dash to be minus 1. So we will have 3 into d square. Yes, right. So if you do this, we will have x into 1 by, if we do replace d is equal to 2, we will have 2 square. 2 square is 4. So 4 into 3 is 12 minus d dash square. So minus 1 square. So we will have only 3 e power 2x minus y. So we have p1 to be equal to x by 12 minus 6 is 9 e power 2x minus y. This is the particular integral 1. Now we need to find pi2. So pi2 will be, our RHS will be e power x plus y. Now I think you can do pi2. So instead of e power 2x minus y, you write e power x plus y, replace d is equal to 1, d dash is equal to 1, you will find the particular integral. So I will straight away write the answer. The answer is x square by 6 e power x plus y. This is the answer for pi2, and for general solution z is equal to cf plus pi1 plus pi2. So if you have finished this problem, we will move on to the next problem. You just find pi2 and you check, and you just text me whether you will get this answer or not. Here you have second derivative, you will have, you do this. Now we want next problem. Here we are differentiating with respect to d. So d dash, you have to treat d dash as constant. So d cube is 3d square, and here d dash is constant. So d dash square is constant. So we have derivative of d is 1. So we have 3 d dash square, and since d dash is constant, this will be the derivative will be 0. We are differentiating d cube minus 3d dash square plus 2d dash cube. Differentiating with respect to d, you have to treat d dash as constant. So if you treat d dash as constant, so derivative of d cube is 3d square, and you have to keep d dash square as d dash as constant. So d dash square is constant. So that means minus 3d dash square is constant. Derivative of d is 1, and this is constant. So we have 0. So we have 3d square minus 3 dash square. Move on to this problem. The fourth problem, d square plus 4d dash z equal to e power x. Again, this is a partial differential equation, homogeneous, both are order 2, and we have degree 2. So first you will find, so general solution will be complementary function plus particular integral. So first we will find the complementary function. For that you need to replace d is equal to m, d dash to be equal to 1. So this turns out to be m square plus 4m into 1 equal to 0. That means m square plus 4m equal to 0. If I take m common, m plus 4 equal to 0. So m is equal to 0, m is equal to minus 4. These are the two roots. D square plus dd dash d square plus 4d dash. Yes, these are the two roots. So our complementary function will be phi1 of y plus 0x plus phi2 of y minus 4x. Now we need to find the particular integral. So our particular integral will be 1 by d square plus 4d dash e power x. Now here I can write this as e power x plus 0y. That means a is 1, b is 0. So we have to replace d by 1, d dash by 0, d dash by 0. So if I do this, we will have 1 by 1 square plus 4 into 1 into 0 e power x. This is nothing but 1 by e power x. 1 by e power x. So we have e power x is the particular integral. Therefore our general solution z is equal to complementary function plus particular integral. You need to add this term and this term to get the particular integral. So I think you have solved all problems in type 2 also. So I'll give you some more problems for you to practice. Let me do one more problem and then we'll stop this video. T plus so tomorrow we will be seeing type 3 and type 4, and day after tomorrow type 5. So for the next 2 days we will be completing this topic. So last problem for today. Fifth problem, solve d square plus d dash of z is equal to e power x minus y. So I think you can find CF for this. I am now only going to find particular integral alone. So if I find particular integral, you will have 1 by d square plus d dash into e power x plus y. Now here a is 1, b is also 1. So we have to replace d by 1, d dash by 1. Sorry, x minus y. B is minus 1. That means d dash b is minus 1. So if I replace this, you will have 1 by, you will find CF in your own, right? You can do this. So this is 1 square plus 1 into minus 1 e power x minus y. So this will be 0 e power x minus y, right? 1 minus 1 is 0. Now what you have to do is, this is our equation 1, you need to differentiate, you need to multiply x, you need to differentiate the denominator. So this means d square is 2d, d dash is constant. If you differentiate d, you will have 1. So 2 plus 2d plus d dash e power x minus y. Now again you replace d to be equal to 1, d dash to be equal to minus 1. So if we do this, you will have x into 1 by 2 into 1 plus minus 1 e power x minus y. So that means 2 minus 1, so 2 minus 1 is 1. So this is x into e power x minus y. This is the particular integral, and you can find CF, and you can just add up CF plus PI. So we have completed type 1 and type 2. So tomorrow we will be solving type 3 and type 4, which is x power r y power s and sin ax plus by or cos ax plus by. So I'll give you 5 problems for you to practice. I'll send photo in Telegram group, right? So I don't want to write. So here already they have given question and they have given answer also. So I'll send 5 problems for you to practice. So you can practice that, right? Yes. So if you have any doubt, you can ask now. So tomorrow we will be completing. Mic, is it audible? So tomorrow we will be continue solving type 2 and type 3, right? So I think these are very easy problems, and you can expect every question. There will be one question from type 1 to type 6. Sure shot, 100% there will be one question from type 1 to type 6. Okay, so we will see tomorrow. So tomorrow we will be completing type 2 and type 3, and then we will solve type 5 and type 6. So Wednesday we will be completing this topic, and then we will see ET equation 3 to 4 days, wave equation 3 maximum 3 days. So 6 days we will completing that, and canonical form that we can finish that in 2 or 3 days. So roughly we can finish that in next 12 to 13 days. So you can finish this course entirely in 20 days, as I said earlier, right? And the important thing is you have to practice the Lagrange's linear equation problems. I have said given the page number. So some of them are commenting in the group that it is not that your answer is only unique. You can get any answer, right? So if someone gets different answer and you get different answer, it is not at all a problem. you have to find 2 solutions, that's it, right? So you don't compare 2 answers. If you think your solution is right, it is right, right? You don't compare any 2 answer, because we can solve, we can take, there are many, infinitely many multipliers you can take, or else you can also form grouping. So it is not that your answer is unique, it is, answer will never be unique. So there will be many solutions, you are finding only 2 solutions, right? Yes, so that's it. So we'll see tomorrow. Goodbye, thank you.